It's a distinct honor for me to introduce Dr. Don Thomas, NASA astronaut. Dr. Thomas was on 4 space shuttle missions and was the International Space Station program scientist overseeing research aboard station. With that, Dr. Don Thomas.
Thank you all. Good morning, everybody. Hey, I'm so honored to be here today. Let me just tell you, when I was your age, for our students out there, I only had the opportunity to watch other scientists doing their experiments up on the Skylab space station or during the Apollo missions. Your generation has the opportunity to actually do your own experiments up there. I think that's outstanding, and I think that's a great opportunity through the SSEP program. So I think you're all really fortunate for that. Well, as you heard, my name is Don Thomas, and I had the amazing opportunity to fly on 4 space shuttle missions. I was on Space Shuttle Columbia 3 times and Discovery once. I've spent a total of 44 days in space, and I've gone around the Earth 692 times. So I've seen a lot of our planet during that time, and I want to share with you a little bit about some of the excitement of being in space, but more importantly, I want to tell you a little bit about my journey to become an astronaut. Now, I always start with this picture. This isn't a picture of me, but it very well could have been me. I was just 6 years old when the first American astronaut launched into space. It was a long time ago, May 5th, 1961. And at my elementary school in Cleveland, Ohio, where I grew up, they brought us all to the gymnasium. I sat on the floor. I watched a small black and white TV of the launch. And as soon as Alan Shepard was in space, I said to myself, I want to do that. So ever since I was a little boy, I knew I wanted to be an astronaut, wanted to launch into space, wanted to experience zero gravity. But as a young boy, I wasn't quite sure how to become an astronaut. There were only 7 American astronauts at that time, and I didn't know any of them. But the one thing I knew of at that time was there was a lot of competition. Thousands of people apply, and then NASA would select a small handful of astronauts. So I realized that the only shot that I would have of becoming an astronaut would involve me working hard, doing my best in school every single day, in all my subjects, not just math and science, but reading and history and art, music, gym. Whatever I worked on, I always tried to give it my best shot. In elementary school, I was an average student, got mainly B's, a few C's, a few A's. In middle school, I started working a lot harder on my schoolwork, and I was getting A's and B's. And by the time I got to high school, I was working really hard and had nearly straight A's. I had 1 B in high school, the rest A's. And I got those grades not because I'm the smartest guy in the world, not by a long shot. I got those grades because I work really hard. I've got a fraternal twin brother who's like a genius. He never had to study at all, and he got straight A's like that. And I think we've got some students like that here today from what I've seen. I was one of those students that had to read that chapter, read it again, go talk to my teacher, study some more, but in the end, I got it all. I learned everything I needed, and I learned how to work hard along the way, which is a great skill later on in my career. Well, after high school, I went on to college. I went to Case Western Reserve University in Cleveland, Ohio, where I grew up. I got my bachelor's degree in physics, and that's the minimum degree you need to become an astronaut, 4-year college degree in math, science, engineering, or the medical field. But again, I knew the competition was tough, so I decided to stay in school, and I got my master's and my doctorate in engineering, in materials engineering from Cornell University. So after 9.5 years of college, I finally got out. I took a job in Princeton, New Jersey with a company called AT&T Bell Laboratories, doing research work on electronic devices. And this was in the early 1980s, just about when NASA was starting to launch the space shuttle, so my timing, as it turned out, was perfect. And NASA selects new astronauts every couple of years. They'll pick a small group of 10, 15, or 20, depending on their needs. And it was about 2 years after I got out of college, NASA made an announcement they were looking for new astronauts. I was all excited. I got an application form, filled it out, sent it in. And I never heard back from NASA that time. It was about maybe 6 or 8 months later, I was reading the New York Times, and there was a little article in there. And the headline said, NASA selects 15 new astronauts. And I thought, well, that's kind of strange. They didn't call me. And I quickly read the article, and my name wasn't on that list. And that's when I realized this was going to be a lot harder than I ever thought it was going to be. Well, I didn't give up. I decided to try again. 2 years later, another astronaut selection. Sent my application in, and this time I heard back from NASA. I got a little postcard, and it started off, "Dear Sir and/or Madam." So you know where we're heading with this. "Thank you very much. We had a lot of good applicants. We didn't choose you, but good luck in the future." And I looked at that postcard, and I thought, my grandmother and I have the same chance of becoming an astronaut. That chance was 0. I wasn't even getting close in the competition. So I decided I need to do more to get noticed out there. So what I did, being an engineer, I studied the backgrounds of the people that made it into the program, the people that were successful, to see what did they have that I didn't have, what experiences, what background, what education, and maybe I could model myself after those folks. So I studied that, and I learned a few things. Most of the civilian astronauts that they select had flying experience. It wasn't a requirement to be an astronaut, but it seemed to help a little bit. So I learned to fly, got my private pilot's license. Most of the astronauts they selected had some skydiving or parachuting experience. Again, it wasn't a requirement, but it seemed to help. So I learned to do that. I taught a university course. I learned to scuba dive. And my thought was maybe I can do enough of these little things that help that maybe for that next astronaut selection, they'll add up and I'll be head and shoulders above the other candidates. So I worked on all those things, and 3 years later, another astronaut selection. I sent my application in, and this time NASA invited me to Houston, Texas, to the Johnson Space Center for a week of medical tests and interviews. And out of the thousands of people that apply, NASA will whittle it down to 100. They bring you to Houston, and you spend a full week on a really thorough medical exam, and then there's a 1-hour interview. I passed all the medical tests, went on to the interview. That went very well. And at the end of the week, I went back to my job in New Jersey and just sat there, waited to see whether I had made it or not. And I was back at my job just about a week or so, and some of my friends started calling me up from across the United States. And they said, "Hey, Don, the FBI's been calling about you." And let me tell you, if the FBI is ever calling about you, it's either really good or really bad here. In this case, it was really good. NASA was doing a security background check on me. And they looked into my background. They went and met with every employer wherever I worked from high school on, talking to my former bosses, asking, hey, what kind of worker was Don? Did he show up to work on time? How did he treat the coworkers? How did he treat the customers? They went up and down the streets in any neighborhood, wherever I lived, asking neighbors on either side, what kind of person was I? Did I stay out late partying all the time? And when I heard NASA was doing this, I thought this is a great sign. I didn't think NASA could do this detailed security check on all 100 people. I figured they must have selected their astronauts, and this is the final check to make sure you're good to go before they announce the names. So I was pretty excited, and it was about a month or so later I got the phone call from NASA, and they said, Don, thank you very much for applying. We had a lot of good candidates. We didn't select you, but good luck in the future. And I hung up that phone, and I was in shock. I thought I had made it that time, but here for the third time, it turned me down. First time, no. Second time, no. Third time, they interviewed me and got to know me, but the answer was the same, big no. And at this point, I decided I need to give up on this silly dream of mine. I gave it my best shot. I worked hard, and I thought it's time to move on and do something else. So I decided I would go to bed, get a good night's sleep, and then in the morning, put together a new plan for what I was going to do with my career that did not involve being an astronaut. So I went to bed that night. The next morning when I woke up, the very first thought that popped into my head was, I still want to be an astronaut. So I asked myself, is there any more of these little things that I can do to improve my background, to make myself a better candidate? And again, by studying the numbers, who was NASA selecting, most of the civilians that they selected were already working at one of the NASA centers. And most of them were working at the Johnson Space Center in Houston, Texas. So I quit my job. I drove down to Houston. I got a job as an engineer working on the space shuttle program. I did that for 3 years. Then there was another astronaut selection, number 4. Sent my application in. I got called up for the medical tests and the interview once again, and that all went well. And this time it was maybe 3 or 4 months later, I got another phone call from NASA. And this time they said, Don, are you still interested in being an astronaut? Because we'd like to offer you the job. And I said something really intelligent. You can quote me on this. I said, habita, 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 ha. And I finally got the words yes out of my mouth. I hung up the phone and I was jumping up and down, yelling and screaming for 10 minutes because I knew I had made it into the program. I was 35 years old when I got that phone call, and I started a 4-year training program for my first flight. So I was 39 years old the first time I made it into space. So my question for you is, what do you think the lesson is from this? Never give up. Never give up is the most important message I can pass along to you today. It takes hard work to do these things. It takes time, and it takes persistence. But if you never give up, I'm quite confident you can accomplish any dream, however big, however small, that you want to in your lifetime. So I went from this little boy just dreaming of going into space to getting assigned on 4 missions. This is the crew from my last flight. And the last time I was in space was nearly 20 years ago. It was in July of 1997 aboard Space Shuttle Columbia. That's a crew from that mission. We've got 2 military pilots in the front row to help us fly the shuttle. On the left-hand side with the helmet is our commander, Jim Halsell. He was an Air Force test pilot. And then on the right-hand side with the helmet is our pilot. Her name is Susan Still. And Susan's a pretty unique individual. She was only the 2nd woman to pilot the space shuttle and one of our country's top Navy fighter pilots. So it was a great opportunity for me to fly with her. And then in the background, we've got 5 of our science astronauts. We're called mission specialists and payload specialists. Our job is to do the science on board. We work the robotic arm on the shuttle if there's a need for that. We deploy satellites and do spacewalks. So we each have our area of specialty on the crew. You probably don't recognize that guy on the far right-hand side, but that's the way I used to look 20 years ago, before glasses, gray hair, wrinkles, and a few pounds around the middle here. There's the shuttle on the launch pad. I took this picture the night before my first mission, and I can't tell you how exciting it was to go out there about midnight or so and just stand there right at the base of your space shuttle, all lit up with those bright lights against that pitch black sky. And I got to tell you, it really got the butterflies going in my stomach. I was a little bit nervous, a little bit scared, but mainly really excited knowing I would be inside there in 12 hours blasting off. They bring us out to the launch pad about 3 hours before liftoff. I've taken the elevator up. I'm just standing there in front of Space Shuttle Columbia waiting when it's my turn to get strapped into my seat. They'll call my name and I walk down that access arm, and at the end of it you see the round hatch for the shuttle. These 2 guys there in the white suits will help me put on a parachute harness and check my equipment. Once we're all set, get on my hands and knees, crawl through that round hatch, and we get strapped into our seat. And it's pretty quiet inside for the next 2.5 hours or so, up until about 6 seconds before liftoff. At that point, the engines start, the 3 main engines. Once they come up to full power, we light the 2 big white solid rocket boosters. And the instant they light, immediately you're on your way. And laying on my back in my seat, I could hear the roar of the engines. I could feel the shaking and vibration going on. And right when those solid rocket boosters lit, I felt this push in my back. And it felt to me as if somebody had their hand right in the middle of my back and that they were pushing me up into the sky. And that's what the shuttle's doing, literally pushing us up in the air. This picture's taken 4 seconds after liftoff. We're going 120 miles an hour already. And I got to tell you, on my first launch, I'm strapped in, the engines start, I feel that push in my back, so I knew we had taken off and I knew I'm on my way to space. I had my helmet on, visor down, nobody in the world could hear me, and I'm screaming inside my helmet, "Yahoo, let's go!" Because it was the dream of my life, and here it is taking place in front of my eyes. We had 3 other rookies on that flight, and I pretty much assumed they were screaming inside their helmets, although I never heard them and they never heard me. So we launched from the Kennedy Space Center. 8.5 minutes later, the engine shut down. It's perfectly quiet, and you're in space. It only takes 8.5 minutes to get to space. It usually takes longer than that to go through the security line to get into the museum here, right? And in 8.5 minutes, you can be 200 miles above the Earth, and at this point, we're traveling at a speed of nearly 18,000 miles an hour, 5 miles a second. On 3 of my missions, we had a science laboratory that you see in the payload bay here. It was called Space Lab. And once we got to space, we'd float through a tunnel, go back there, and we'd work on different science experiments. There I am with Greg Lantiris, one of our payload specialists. And during a 2-week mission, we'd work on typically 100, 200 different experiments in space. Just want to tell you quickly about 2 of these. We did a lot of experiments on this mission looking at how fires burn. You know, a flame comes up to a point here on Earth because of convection. Hot air rises. In space, that doesn't happen, so flames burn perfectly round. And you're looking at a pink droplet of butane fuel, like what we have in a disposable lighter. We set it on fire, and that blue ball or flame that you see there is the fire burning. And it'll consume all the oxygen around itself and then go out all on its own. And scientists study things like this. We're trying to understand some of the basic fundamentals of combustion. How do things burn? And how does incomplete combustion take place when we have soot particles and other pollutants? And hopefully from these experiments in space, we can improve our burning processes here on Earth for power plants, automobiles, things like that. We also take up a lot of plants and animals. This is a Japanese red-bellied newt. And the salamander would lay eggs. We'd watch how they grow and develop in zero gravity. They were very similar to frog eggs developing into tadpoles and baby frogs. You'd see gills forming and arms and legs. And we were just looking for anything unusual that may happen in zero gravity. This is Chaki Mukai, the first Japanese woman in space, and I flew with her on my first mission, and she's just floating through the air into our science module called Space Lab there. And here's Susan Still on my last mission. She's typing on a laptop computer there on the right-hand side. And I just want to point out one feature of this picture. You see how she's got her toes hooked on that vertical gold pole? If she didn't do that, every time she'd hit the keyboard on the computer, what do you think would happen? She'd go floating up. One of Newton's laws there, for every action, an equal and opposite reaction. But if she just hooks her toes a little bit, she can stay in position, float in the air, type on the computer all day long. So space is a really fun, comfortable environment. And in space, there's no up or down. Wherever your head is pointed, that direction is up for you. Wherever your feet are pointed, that's down. And as you change your orientation, your brain automatically readjusts your frame of reference, so you never feel like you're upside down, it's everybody else in the room. That just tells you a little something about the ego of an astronaut, right? It's not me, it's you. And exercise is really important in space. We don't use our muscles at all up there, and our bones get weaker, so it's very important exercise. We had this little bicycle we'd ride on the space shuttle every day for about 45 minutes. Get your heart muscle going, get your leg muscles working so that we're in good shape when we come back at the end of the mission. Some of the astronauts used to make a big deal about it. They would say, I want to bicycle across the Pacific Ocean. And if you ever hear that claim, don't be too impressed. It only takes about 15 minutes. And sleeping in space, we have a display here of Discovery. You can go in there and see. We just sleep in sleeping bags. You stick them on the wall. You can stick it on the ceiling. It's really a comfortable environment up there. Well, let me share with you a few images of the Earth. And that is the greatest part of being up in space. My favorite part was looking out the window at planet Earth. And I've got a map in my hand there. I'm looking out one of the windows towards the tail end of the shuttle. And this is what I get to see when I look out the back. So that's the Earth from 200 miles up. All the blue in this image is the Pacific Ocean. You see Baja California, that peninsula coming down with the south pointing downward there. And if you look carefully near the bottom edge of this picture, either to the right or to the left of the shuttle, you'll see a really thin little blue line. Do you know what that blue line is? That's our atmosphere, exactly right. On a nice sunny day like we have today in Washington, you look up at that blue sky, it looks like it goes on forever and ever. From space, we see that atmosphere edge on. And it looks just as you see here as a paper-thin layer. And I think every astronaut, everybody who goes to space, they come home with a keen appreciation how fragile our planet is and a realization that we all have to take better care of this place. Here's a giant hurricane, big storm about 400 miles across. We flew right over the top of it, excuse me, and from 200 miles up, I could look right into the eye and see the blue water of the Pacific Ocean. So to see sights like this from that vantage point are spectacular. Here's a volcano venting steam near Indonesia in the South Pacific there. And here you see the Himalaya mountains. And at the very center of the picture right there is Mount Everest. And that's right here. And right there are the very top of Mount Everest. Now, I can stand up here in front of you and tell you without lying, I have seen the top of Mount Everest with my own eyes about 25 times during my missions. I'm sensing you're not too impressed by this. I call it the lazy man's way to see the top of Mount Everest. No climbing involved, but I use this picture to illustrate some of the things I got to see and do. I've never climbed Mount Everest, never will, but I've seen the top of it many times. I've seen the Great Barrier Reef. I've seen the Amazon rainforest, Mount Kilimanjaro, so many amazing sights around planet Earth. And this is a sunrise from space. Because we go around the Earth every hour and a half, we see 16 sunrises and 16 sunsets every 24-hour day. And they're all a little different and spectacular. I tried to catch as many of these as I could each and every day in space. Then at the end of the mission, we would fire 2 engines and return back to Earth. Our fall back through the atmosphere took 55 minutes or so. We would end up landing like an airplane back at the Kennedy Space Center, touch down, deploy that drag parachute out the back. And when you first come back from space, you feel like you weigh about 2,000 pounds. You're just so heavy with this pull of gravity again, and a little dizzy when you get back. And it takes about a day or so for that dizziness to go away, and maybe a week or so to get your muscle strength back after a 2-week flight. So this picture was taken about 2 hours after I landed on my first mission. I'm there on the left, and on the right is Bob Cabana, my commander. He's currently the center director at the Kennedy Space Center. And after we took this picture, I remember turning around and I looked at the space shuttle and I thought, what an amazing vehicle this is. You know, this was my house in space for 2 weeks. This thing protected me from the fiery re-entry coming in through the atmosphere. And then one of the next thoughts that popped into my head was, I gotta do this again. And it's like going on a great roller coaster ride. If you've ever done that, sometimes you'll get off, run around, get back in line and do it again. I don't know if you do that, but I always do that. And that's exactly how I felt when I landed on my first mission. I knew I wanted to do that a few more times. So that's a little bit about my adventures in space. I want to tell you just a few minutes about something that you can all look forward to. You've got experiments up on the International Space Station. We're going to keep flying this currently right now. It's funded through 2024. But NASA's working on a new generation of launch vehicles, as you heard this morning, called the Space Launch System. And these will be bigger and more powerful than the Saturn V moon rocket that sent Neil Armstrong to the moon back in 1969. And we're also not using space shuttles, but going back to a capsule. This is the capsule called Orion. And this will hold between 4 and 6 astronauts. The first test launch of that Space Launch System is just about 1.5 years away. So we're building these, we're designing them, we're testing them right now. And we're just a year or two away from starting to launch these. And these rockets will have the capability of going to the moon, going to asteroids, and onto Mars. Those are just some of the destinations that we'll have the capability to explore in the future. So these are artist drawings of some of these potential missions. Maybe we go back to the moon and build a lunar base to learn to live independent of Earth. Maybe we visit some asteroids. We'd love to bring back some samples of the asteroids. These are early remnants of our solar system. Maybe we land on one of the 2 moons of Mars. I think it would be so amazing to be this astronaut in the lower right-hand corner, and you look in the background there, and you've got the incredible red planet Mars behind you. And hopefully 20 to 25 years from now, we hope to send astronauts onto the surface of Mars. And this is an artist's drawing of that day. So you see the landing craft, and to the right of it, you see the little shadows of 2 figures there, the first 2 humans to set foot on Mars. And do you know who those astronauts are? Me? I'm too old, right? I'm too old to go to Mars. It's your generation, all of our students here today. We call you the Mars generation. So I'm too old to go to Mars. Your parents are too old to go to Mars. Never repeat this one at school, but your teachers are too old to go to Mars. But you represent that generation. You're the perfect age to be these astronauts, these explorers, the scientists, the engineers working on these programs. And that's why it's so important that you work hard in school right now on all your STEM subjects and everything else. We need you for the future. We need you for these missions. We need you for a lot of other things that are going to be going on in our country. There's a lot of new technology that you'll be developing and inventing that we can't even dream about yet today. So that's why we need you working so hard, and I'm so proud to be here today to hear your presentations. And when I hear what you guys have done, I'm really confident that you're going to do a great job on these missions in the future. So I wish you all the best of luck, and I thank you very much for your attention here this morning. Thank you all. Thank you. You want to take any questions? What's the reasoning behind going back to the capsules? Well, we learned in the shuttle program, the space shuttle was kind of fragile. We had 135 missions, and 2 of those we had bad accidents, bad disasters with that. When I sat in my seat inside the space shuttle, I'm sitting maybe 5 or 6 feet from 500,000 gallons of explosive liquid oxygen, liquid hydrogen. So going back to the capsule, putting it on top of the rocket, if something, the engine should explode, if there's some problem with the rocket, the capsule can pull free and parachute down, and our astronauts have a better shot at surviving on that. So I think that's one of the main reasons. It's just inherently safer than what we had in the space shuttle configuration.
Any additional questions? Come on up.
Hi, my name is Herschel. I'm from Jersey City, New Jersey. My question is, if there was an explosion in space, how would it look like? I ask because of your work with fire aboard the ISS.
Yeah, if there was an explosion in space, like a big explosion,
Yes.
you know, the oxygen, you need oxygen for that thing to go off, but it's going to happen really quick. Once you consume all that oxygen, it's just going to go out almost instantly. So I'm sure it would be a bright flash, but once that fuel was consumed and the oxygen was gone, and I think it would evaporate pretty quick or disperse pretty quickly up there, that fire would go out. If the ISS exploded, you would need all of the oxygen tanks exploding all at one point there, all the fuel tanks on board the shuttle, so the space station. So I don't think it would be a huge fireball like maybe you're used to seeing in the Challenger accident where the fireball engulfed the entire space shuttle. I don't think that would happen. It would be a smaller, isolated event, maybe like what we had on Apollo 13 when we had an explosion in an oxygen tank.
And just one more question.
Calvin, San Antonio, Texas. You mentioned that you were dizzy for a couple days when you got off the shuttle. When you first got on, was there any kind of dizziness?
There's no dizziness when you get up there. What happens, our inner ear that we use for sensing gravity, it kind of shuts down in space. And when you come back to Earth and the gravity again, it takes a day or so for your brain to reincorporate that, and it's very sensitive. Just a little tilting of your head up and down got the whole room spinning, like somebody had spun me 100 times.
Vertigo.
So if somebody calls your name when you come back from space, you don't do that. You know, you just slowly, you know, turn around to talk to them. And you'll see astronauts, they'll be walking down the hallway in the astronaut office, they turn the corner, and all of a sudden they're dizzy. Just from turning their head, from the simple act of turning around a corner as you're walking there. So it's very sensitive for the first day or so. And then you're pretty much.
Are there any of the astronauts that developed severe cases of vertigo after getting off, which lasted longer than the 2 days?
Some of the astronauts are very dizzy and nauseous when they come back. It's an individual thing. And usually it's better your second flight and third flight. I was, you know, dizzy. Almost everybody's dizzy when you first come back. But the symptoms, the range of the symptoms, it just varies with astronaut to astronaut. And it doesn't last very long. You may feel a little dizzy there for a day or so.
Good. Thank you very much.
All right, let's thank Dr. Thomas for joining us
Hey, thank you all
today.
very much. It's been a great honor to be here today. Thank you all.